Good morning, everyone. I want to go over a few of the problems on this worksheet. A couple of them were giving you some trouble. Number two was one that was giving people trouble simply because it doesn't actually have a standard base, but in this case, NH3 is actually acting like your base. We never really covered Bronsted-Lowry acids and bases, and that's what this is, just because we never had time. But whenever you're looking at an acid and a base reaction like this, we still only have one hydrogen in our acid, and that one hydrogen is going to end up going to NH3, making it NH4 plus ammonium. So my ratio for this is still 1 to 1. So to set this problem up, I would still take 9 milliliters times 0.7 molarity equaling 35 milliliters times M2. Divide over 35. And my new molarity for NH3, or for HClO4, is going to equal 0.18. The other one like that was number 3. Actually, not number 3, sorry, number 4. Number 4 is very similar. Again, we don't have a traditional acid and base. We have a Bronsted-Lowry acid and base. But the same is going to hold true. Okay? Your KCN is going to act like your base, while your HClO is still going to be your acid. So I still have M1, it's backwards. I still have a V1, an M1, and a V2. So in this case, again, it's 0.36 times 37, and that's going to equal M2 times 75, divide by 75. And my new molarity is going to equal 0.18. Okay. The other ones that you guys were having trouble with were 7, 8, and 9. So let's take a look at 7 real quick. And I'm going to move it over, and we're going to do this together. So it says that a volume of a 250 milliliters of 0.25 molar aluminum hydroxide neutralizes a 75 milliliter sample of H2SO4 solution. What is the concentration of H2SO4? And then it tells you, it gives you the hint, okay? So most of you picked up that there are basically 3 hydroxides and that there are 2 hydrogens, which is good. Okay, so I know my ratio is actually 2 to 3. Okay, so let's go ahead and let's set this up. I know that I have an M1 and a V1. Here's my V1, here is my M1, but because it's OH3, it's going to be 3 times M1. Then I'm going to go to my H2SO4, and I have 75 milliliters. This is going to be my V2, but because it's H2, it's going to be 2 times M2. So what I end up with then is I end up with M1V1, so 3 times 0.25 times 20 milliliters. So this is my M1 and this is my V1. And it's going to equal 2 times M2, because it's 2H2SO4, times my V2 of 75 milliliters. So again, this is M2 and this is V2. Now, what I'm going to do is I'm going to divide then by my V2. So I'm going to divide this over. 2 times 75, they cancel out. Divide this over, 2 times 75. And I'm going to get a new M2 of 0.1. Okay, Look at number 8. Number 8 is a little easier because I have a 1 to 2 ratio, 1 hydrogen, 2 CaOHs. So if I'm looking at this, I'm going to go ahead and do what I did before. I'm going to assign my M1s, my V1s, my M2s, my V2s. So this right here is a V1. This is an M1. This is a V2. And this is going to be M2, but because it's OH2, it's going to be 2 times M2. So now if I look at this again, I'm going to take M1 V1 equaling M2 V2. So my M1 was 0.40. My V1 was 135 milliliters. And this is going to equal M2, which I said is 2 times M2, times my V2 of 90 milliliters. Okay, I'm going to divide by 2 times 90, 2 times 90, and what I'm going to get for M2 is going to be 0.30 molarity. Number 9 is the exact same thing. Okay, we're going to set it up just like we did. Here I've got a V1, here I've got an M1, here I've got a V2, and here I've got an M2, but because it's OH2, it's 2 times M2. So if I go ahead and set this up, I have M1 V1 equaling M2 V2. Okay, again, my M1, 0.60 molarity times a volume of 60 milliliters. And this is going to equal 2 times M2 times a volume of 80 milliliters. So 2 times 80. It's a horrible times. 2 times 80 divided by 2 times 80. And then I'm going to divide that over. They cancel out. And I'm going to get a new M2 of 0.22 for CaOH2. All right. Hope that helps you guys. Good luck. Have fun the rest of the summer.